Helical fresh, bruh.
What up, YouTube? Okay, so this is the first of many what I'm going to call the case studies. Right, so I'm going to break down products that I've been involved with in the past in terms of design and machining, okay, and you're going to listen and you're going to absorb something from this video. Now, let's go back maybe 18 months. So, one of my friends approaches me, he's a big vapor. You know, all that jazz, all that smoke and all that business, okay? He's like, Jordan, bro, all my tanks are rolling around, right? I'm spilling juice everywhere and I need something to hold them so that they don't fall around everywhere. I was like, yeah, no problem, man, easy fix. Let me have a look. So, these tanks and these drippers kind of look something like this. And I was like, okay, cool. Let's measure it up, let's get something drawn up. How many tanks you got? I've got 4 tanks. Okay, no problem. So, we've got our brief. Let's go. So, the product that I came up with was this, okay? Called the Vape Arc, because it's an arc for vapors. Anyway, so, he wanted it out of billet aluminium, halloumi cheese, why not? He wanted it out of billet aluminium machines because he's like into bikes, into motorsport, cars and everything that's cool. So yeah, that's not a problem. I can do that for you. So I did that for him. Now this video is about me explaining the design and how I came around for this and how I machined this, but also the potential for this product to develop. Now when I came up with this idea and machined it for him, I didn't realise the potential market that there was out there. I just thought, dude, I'm solving a problem for one of my friends, which is fine, you know. I came up with the design, I came up with the prototype and the goods, and it came out ace. He was happy with it, ideal. Now, I didn't know that vaping was such a big, massive thing, and thinking about it now, this product could have gone like boom through the roof. Like, this video is not me saying, let's buy these. I'm not selling this, I'm saying that this is what I came up with to solve a problem. If you want to go out and make your own, that's fine. I've no doubt in my mind that people will see this video and go, God damn, what a good idea, boy. I'm going to go out and I'm going to make me some vape arcs. Which is fine. If you want to do that, that's fine. You can pay me for the idea. Yeah, I know what you're all about, you bastards. Anyway, let's get straight into it. And I'm going to show you the development and how the potential for this product could be ideal for somebody who wants to set up a small business who doesn't have access to CNC machines to machine billet parts out all the time. Let's talk a little bit about casting and fast casting at home. Okay, so this vape arc, what maybe costs, like let's break it down. Like for me to be able to buy this material in and machine it, not including my time or anything, just the cost of the material, we're probably looking at about £3 English. Okay, that's how much the material costs. Now, that's not taking into consideration all the machine time, all the programming, all the design work that went involved with it. Like, that's irrelevant. This was just to help one person. Okay? Now, look at this. Okay? So, this is this part, but in a fast cast polyurethane. Okay? So I made the silicone mold from this, right? And I poured it to create this. Now, let's think about this. This cost me literally 3 pence to pour. It took 18 minutes for it to set and demold, and I can machine the bottom of it so it's completely flat like this, right? What would you buy? If these were in the shop at the same price, right, in different sides of the world, you wouldn't know. You'd pay the same price, right? The guys who are doing this are making far more money than the guys who are doing this. Trust me. Now, I'm not turning around and all the machinists are going to be like, oh my God, you're ruining our trade. No, that's not the case at all, right? The people who want billet aluminium or aluminum, right, that's fine. Like, if they're going to pay the price, they will pay it, right? But this opens up the doors for a completely different market. you should consider your product, right? Does this need to be in aluminium? All it is a stand, right? But the same part in a plastic cast at home, you could do 40, 50 in a row at a time. But this was the key. So you pay once for the machining of this, and then you've got it forever to make these. Now, you tell me, what's better? In terms of small business, which one would you be buying? And which one would you be selling? That's a good, stupid question time. Okay, so let's take a look at this and what we've come up with. Right, so we've got these tanks, right? These are all 22mm diameter tanks, right? And we've got, see the little bore holes down at the bottom? So these are to take the flange. I mean, this is just a rough prototype, so it didn't really matter what it looked like. The finish wasn't relevant. But obviously what we need to do is match this parallel edge with obviously the parallel of the table. So that means spacing it out. That's just like, I wouldn't say it's clever design, that's just kind of standard issue. That's what we need to be doing. So it sits flat and it's not going to spill juice everywhere. Now, that was not this was the original. If you'd noticed that I'd not put the counterbores in, now that was just me being completely stupid and forgetting to take into consideration that little boss on the end with the thread on it. So I lowered the wall thickness. I thought it'd be okay, the wall height here on this edge tank. So I actually raised this, and then drew up these little counterbores in the bottom. It's a good little product. It looks nice, okay? When it comes to, like, you know, consideration for design, I mean, originally I just thought like knuckle duster shape. I thought it was pretty good, but I mean, this is a very simple part to CAD up and very simple part to machine. There are various different ways you can approach to machining this. You could use an adaptive strategy to clear most of this away, especially with this kind of rake that goes over on the arc. We need to cut away most of that. Then we'll ball track across all this top section just to clear out any remaining material. And then basically just run round the contours. So we'd be selecting that contour and run round it, you know, with a slot drill or an end mill, and you'll come out with this. But obviously we've got to deck the material off the back, so it'd mean creating some soft jaws using that contour, that profile, inside a vise to hold it properly upside down, and then just come in and skim off all the remainder of the material. Now, if I remember rightly, this took about 6 minutes to machine with all the bores and all the counter bores, and then literally like 30 seconds to deck all the material off the back. Now, I mean, when you say 6 minutes, it's not long. In the long run, I mean, traditionally in the UK, I don't know what it's like in America, but in the UK, we standardly charge around £70 an hour for machine time. So potentially you could probably make 10 of these an hour, you know. It's all reflect on the end price if you sent a product like this to market. But overall, like, nice little product. It did what it was meant to do, apart from then he decided that he was going to get bigger tanks. So the design had to change. It's interesting sometimes to watch how a product develops. So from going from this to this with the counter bores, you know, which fit everything properly, to these cast parts. Now, these cast parts haven't got the counter bores in the bottom because I literally just used this master to create the mold in silicon. Now, that doesn't really matter because this was just a test. The counter bores will still come out in the shape of the silicon mold, but the advantage of this polyurethane casting resin is that the finish that it comes out with, you know, it's shiny, it's acceptable, you know, and this material is machinable as well. It's really rigid, it's really tough, you know, it's like it's been injection molded, but without the cost of having to go through injection molding. Now, this is a big game changer when it comes to people who are running a small business. It's important that you maybe consider using an alternative material when it comes to creating a small product, because if you think of these are pennies to produce, whereas these are a lot more expensive, and you don't have the access to machines. You're going to be paying out for machine time. So think to yourself, is it worthwhile, you know, getting maybe 1 or 2 of these made, you know, by a machinist on a CNC machine, and then at home learning how to use RTV, that's room temperature vulcanizing silicon, to be able to produce your own silicon molds at home and then pour your own parts. And literally this stuff is so good. Like, I can't emphasize how good polyurethane is. Yes, it's not ABS, you know, it's not polytepylene epithate or whatever you call it, PET, but irrelevant. It's not 3D printed inferior material that takes forever to make. Literally, this stuff, it cures in 7 minutes, and within 18 minutes you can pull them out. So if you stacked up, if you imagine creating a mold, designing a mold, and putting together a mold box and pouring silicon over the whole thing and creating maybe 10 in a batch, all you got to do is mix up 1 batch of the polyurethane, and then bang, you've got a load of products without waiting for machine time. They can cure overnight. It's very interesting to see if anybody's going to take this on board and start using this kind of method rather than just basic machining. But so when I finished machining this for my friends and casting this to show that I could do it in plastic as well, he turns around and says to me, "Oh, one of my tanks doesn't fit." What do you mean it doesn't fit? You told me they were all 22, 24 mil. Oh no, this one, I got a bigger one now. Like, this one's like 28 mil, and I'm thinking, for God's sake. He's like, "Is there any way that we could bore this out to accept the tanks?" No. The way that I designed this, it cut through the edges. This was designed for one size tank only, and it was a good design to use out of inch square billet bar. So I was like, it's going to be a nightmare. I started designing different things, coming up with different shapes. It was not ideal at all. So back to the drawing board. I need to find a quick, cheap, fast way of producing something like this, or something to hold the tanks that solved all the problems, so that if they went out and bought a new tank, they could adapt it, right? So this is where the development came in. And this is where was the born truth, identity, or whatever you want to call it, of what was called the vape hanger, okay? It was funny calling it the vape hanger because my friend's into Harleys, right? You know, the ape hanger bars? So I just took it, twist on words, vape hanger. Boah, branding and marketing for the win! Now, going back to what I said before with problems on the horizon, where Adam turned around to me and says, "Oh no, one of my new tanks doesn't fit." Okay, so we need to adapt it to be able to fit a bigger tank. Now, because I had measured these, and these are 22.5 mil bores, there was just no potential to actually open these out to 24, 26, or I think 28. And I think he's got a tank that's 32. It's getting out of control. But that means that this was irrelevant. But then came the birth of this. Okay, so this is what I called the vape hanger. Let's get into it. Okay, so the vape hanger. So this is multiple parts, right, that I designed, created carefully to be able to produce a hanging bracket which was adjustable for people to be able to modify, stack up, add more of these ringlets onto it to be able to adapt and take bigger tanks, smaller tanks, you name it. Like, it was perfectly adaptable. It's in a cheap material, right? And pretty much this whole design, is laser cut. Okay, using acrylic, 3mm acrylic, and basically, it's very cheap, very easy to make. This is acrylic rod, which I put on a lathe and tapped. Okay, to take a screw, which goes there. So we've got an M6 bolt there, and that's the base. Now the base is cast acrylic that I machined, but it didn't start out life as that. Originally, it was machined billet aluminium, okay, and it was counterboard on the bottom, countersunk, to take the screw, and then I was going to use a bit of aluminium bar, but then again I was looking at it and the price was jumping up again, right? It was unfeasible for me to produce this at a decent price, right? So I had to think again about material selection and what I was going to do to make it cheaper. And what you have to appreciate when it comes to this product is its simplicity, its form, right, and its ability to be able to look aesthetically pleasing and be able to be very cheaply manufactured. It's important that if you're going to start a small business or you're going to release a product that's going to be available to the masses, that you correctly choose a material that's going to be ideal for the application, that's not going to put you into huge amounts of debt from making it because you might have stock laying around. But it's also important to be able to put it onto the market or sell it somewhere where you're not ripping people off, but you're covering your back and you're making a little bit of money out of it. Now, as I said, this started out as per, this is what I always do, is that I'll machine it out of aluminium, right? And it's nice, it's cool, but it's like I said before, this part took a long time to machine purely based on aesthetics because of that radius that goes over the whole thing. If you notice, there is actually a flat machined on top so that it takes a lot of the strain and the weight, also so that this butts up flat against it. Now, as I went back to saying before, we have one in acrylic. Okay, I thought, oh yeah, acrylic looks better. It fits in with the acrylic tags that stick onto the acrylic tube on top, and I thought, yeah, that looks better. It does look really good, but again, continuous cast acrylic is so expensive, and it is expensive to machine as well. You need to use high-speed steel cutters to machine it, lots of coolant, it can go wrong, it can crack, it can do all sorts. It's not ideal for the application. So, moving back, I thought, yeah, this is cool, but they were just taking too long to produce. So naturally, what did I do? I machined this part, then I made a silicone mold, and then made the base. So again, pennies, it's hard, it's rigid, the finish is absolutely perfect for the application, right? Then all I needed to do afterwards was drill out the center hole, flip it around, countersink it, put the countersink screw in it, and again, put these little rods in. Now, you can even cast threads, fine threads like this. You can actually turn one of these down or get someone to turn one of these down for you, make a mold and actually make that cast thread. Even still, you can drill and tap these at home, no problem. But this is just an example of a product that came together. It was a good development and it was a nice little cheap product that I could actually put to market. Assembly is basic and straightforward. M6 screw in the bottom. I apologise to the Americans who don't like the metric system. Don't worry guys, you'll click on soon enough. Okay, so these parts are actually what support most of the weight. Now all these go on first. Simple. Slide it on. So these are all laser cut, right? Even if you don't own your own laser cutters are very cheap to buy now. But also a lot of these hack spaces where you can go and actually make your own parts and stuff, they have lasers. You can book laser time very cheaply. Acrylic is pretty cheap. So if you notice there, I just put a rubber O-ring and all that does is just slightly grip. Now, how you actually set this up is you just rotate every part 90 degrees. But it can be a bit of a pain holding on to things. It's easier when you've got some of the tanks to actually support it. But you get the idea, okay? It looks nice, it's an aesthetically pleasing product, okay? People would buy that. Now, I could market that and sell that at 10 British pounds in the shop, and I believe that people would buy it. Because the best part about it is you can sell consumables with this product, sorry. So this is actually cleverly thought about in design. So that center shaft, right, just by making it higher, right, you can sell those consumable parts, right, with extra O-rings and sell these separately as well in different diameters, internal diameters, to take different size tanks. And you can actually stack this up, right, and continuously hang all these juice tanks for ages, for days as they say. So yeah, it would have been an ideal product to launch. We've got our nice little assembled pretty little product that people want to buy. That's great, but you've got to remember, you've got to have a standard of professionalism when it comes to actually trying to sell a market to a distributor or a shop to actually force the product for you. Now, this is where it all comes down to marketing. You need to know your market, you need to know what people are after, you know, what you look at the trends, look at you know, how these vape tanks are made, the colors that they use, the materials that they use. By making something that looks very similar, people like it because it's going to match. The good thing about, you know, doing something like this in acrylic, in sheet form and laser cutting it, is that the colors are endless. You can sell so many different colors: opaque, frosted, you know, transparent, colored, just clear. Anything that you want is available in acrylic. You could have solid color, metallics, anything. But it's also important to be able to actually package a product as well. So from here, I actually sourced these, and these are relatively cheap. This is a massive tip for people, right? I believe that if you go out and buy a product, you should buy it in something that's acceptably, you know, well, basically a product should have a packaging. It's got to sell itself, right? So these little tins, right, they're very cheap to buy. You can buy these. I mean, I think these are like 70 pence. So like $1 per tin. So it's worth looking into places that just sell these tins. Now, what I did inside this tin was, oh, see, there's a purple one in here already. I didn't even know that was in there. So, well, that's tight, but the tight fit's good. Okay, so inside there, I actually laser cut. That was a different base, an original base that I didn't like. But I actually laser cut some neoprene foam. Put some foam around the outside of the tin, and basically this profile would stick inside the foam at the bottom, and voila, you've got packaging protection. Like, that's stiff, that's not going anywhere. All you need to do then is get somebody to print you some nice vinyl stickers, stick one on the top, and bang, you got it there. You can sit that on a counter in the store, and people are looking at it and go, that's lovely, I'd buy that. Here, take my money. Okay? It's important that you think of every aspect, even down to packaging, if it's something that you want to launch. So bear that in mind. Always, rather than trying to have your own packaging made, look at what already exists. Look at what cardboard boxes you can get, what plain little aluminium tins you can buy, and then just think about you know, having your logo printed on stickers, just basically just to stick them on top or on the sides, product information, whatever, Instagram page, Facebook page, Twitter page, anything. Okay, it's important. Think of all aspects of the design. Have some pride in your work. Right, guys, so that's basically it for this video, this little case study on the Vape Park and the Vape Hanger. Okay, two nice little products. It's just a little bit of inspiration for you guys to maybe assess your own products. Is there any development in it? Can you change the material selection that you've got? Can you put it into a new, cheaper format that everybody can afford, rather than just focusing on billet material? Why not have a look into other materials? You know, thermoform plastics are great, but also there's the cast, you know, plastics that you can do at home. Have a look on YouTube. I mean, I don't mind if somebody wanted me to do a video on casting and explain about how to design for, you know, mold making and casting. I'll happily do that if you want me to do that. But I just hope this video has been a little bit inspiring for you, to go out and then have a look at your own products and see if you can use any of these tips and put them into your business so that you can make a little bit of extra money and then put some development into another product. Thank you very much for tuning in, guys. We'll see you next time.
Oh my god, Larry, I forgot to check the digital readout. Cycle star, ends mill, face mill, slot drill, twist drill. Oh my god, do you know conversational CNC? Man, I bet the chicks dig you, son. Helical fresh, bruh.